Okay, afternoon, guys. So we're gonna try and see if we can do a little more on probability, but this time we're actually going to calculate it. So you guys now have the vocab when you're talking about it. You just need to make sure you know how to start calculating with it. Okay, so there's a couple of ways that people usually talk about it. One is where they'll just ask for the probability, or one where they just actually give you the notation. So at the top is the notation, and then down here is more wordy, so it's a bit more problem solving like. Okay, so dealing with the top part first, it says a fair dice is rolled. Work out the following probabilities as simplified fractions. Okay, so it's a fair dice. So we know the dice, it's one of those wonderful things called a cube. I don't know, I'm just going to put one there, two there, and three there. I don't actually have one, otherwise I would pop one on here. They're all at school. I'm so sorry, guys. You're just going to have to deal with my wonderful sketch. But anyway, a fair dice is rolled and it says work out the following probabilities. So when I pop this down, I am essentially saying what's the probability of getting 1. So when I am writing down probabilities, I need to make sure that I write down however many chances I have of getting 1. So on a fair dice, i.e. we have 6 faces, which is 1, 2, 3, 4. I don't know why I'm doing that because it's there and you couldn't see it. So 6 faces on a fair dice with 1, 2, 3, 4, 5, 6, right? Okay. So there's only one chance of me getting a 1 because every other one just wouldn't be a 1. Okay, and underneath I'm saying how many different outcomes could I have in total. So outcomes just means what different outcomes could happen. So at the bottom, when I roll a dice, what are the different outcomes I have? 1, 2, 3, 4, 5, 6. Okay, so there's 6 different outcomes. 6. That's my probability. That is literally all you have to do to find out probabilities. So if I had this, what would this mean? Well, it's a probability of me getting a 3. Okay, so if I roll a dice, how many sides have a 3 on them? Well, 1. And how many sides do I have in total? 6. Okay, what if I tried 1 or 2? Well, how many sides have a 1? Well, I have one of those. And how many sides has a 2? I have one of those. So altogether, I've got 2 sides. Still, for the bottom, I'm still asking the same question. How many sides do I have in total? 6. Okay, I know up here it says simplified fractions. But in all honesty, when you are working out probabilities, if you leave it like this, that's perfectly fine. Because when you're doing probabilities, most of the time they don't actually ask you to simplify. Okay, and sometimes, especially when you move on to further probabilities within like 9, 10, and 11, if you start simplifying before you kind of reach the end, sometimes it can make your work a little bit trickier. And so it's actually easier just to leave it. Okay, so 2 over 6. What if I try P, 1, 2, 3, or 4? Okay, so how many faces have a 1? Well, there's one of them. How many faces have a 2? Well, that's another one. How many faces have a 3? That's another one. How many faces have a 4? So that's the 4th one. So there's 4 different possibilities that I could have. And then altogether, how many faces do I have on a dice? 6. That's my probability. I know it sounds easy because it is. Okay, and then the only one that might be a little different is not a 6. So if you remember the Venn diagrams when they're talking about a complement, this is what they're talking about, a complement. So when I'm saying it's not a 6, that means it can be 1, 2, 3, 4, or 5. Okay, so if it's 1, 2, 3, 4, or 5, that is 5 different possibilities. And how many different possibilities do I have altogether? 6. I know, super easy. Okay, so that would be the top half. So when you have the top half and you have a probability, so if you wanted to make it all formal, you'd have I'm going to say probability of desired outcome. This would be chances or outcomes, number of outcomes of desired outcome happening. And I've just realized this is too small. Okay. Total number of outcomes. Sorry, I've just realized that this page is not very big, so now I'm squishing everything together. So when you have the probability of a desired outcome, you have the chances of the desired outcome happening all over the total number of outcomes. So that's exactly what we were doing when I said 1, the probability of getting a 1. So the desired outcome is to get a 1. How many chances do I have of getting a 1? Well, I only have 1 on a dice, right? And how many chances do I have of any outcome on a dice? Well, there are 6 faces, so there's 6 different outcomes that could happen. Does that make sense? So this is just formalizing it a bit, but as long as you understand this part is the important part. If you get that part, you're sorted, okay? This part, as long as you kind of understand what you need to do. Most of the time, people don't really write this one down. It's because this is kind of expected. Probability isn't usually just this. You usually have more steps to it. So as long as you get how to do this part, you're A-okay. Okay, so now for the second part, where it goes into wordy-like questions. Okay, so we've got the words. It says the letters which make up the word mathematics are put into a bag. A letter is taken out of the bag. Write down as a fraction the probability of choosing a theorem or a vowel. Okay, so I'm going to say we have mathematics, right? Okay, so I'm going to do my colors because I like my colors. Okay, so when they're talking about A, I could actually theoretically say it's probability of getting an A, right? So, how many A's do I have? I have 1, I have 2, so there's 2 chances of getting an A. Over how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters altogether. So there's 11 chances altogether, but only 2 of them are an A. Yeah? Hopefully that makes sense. The next one is probability of getting a T or an M. Okay, so first of all, I'm going to go for the T's. So I've got 1, 2, and then the M's, 1, 2. Okay, so that's 4 of them altogether. And how many tiles do I have? Well, we've already counted them. We said there's 11. And last but not least, probability of a vowel. Okay, we're just going to accept the normal vowels. We're not going to go for any half vowels or anything else. So we're not having any like H's or Y's or anything else. So it's just the normal vowel, the normal A, E, I, O, U. So how many A's? Well, I've got 2 A's. E's, got 1. I, got another 1. O, nothing. U, nothing. Okay, so altogether I've got 1, 2, 3, 4 vowels. And how many tiles do I have altogether? 11. Make sense? Okay. So probability is one of those things. It's very instinctive. You should find it shouldn't actually be that difficult. So if you're thinking it's too easy, it's probably just because it is. Okay. It is actually quite an easy topic. So once you pick it up, it's like this. If it's a little bit confusing, it's just because you haven't got it yet. But once you've got it, you'll be like, how did I not know that? Okay. So I am going to set you, both of these come from 2 different sheets, so I'm going to pop both of these sheets on there. I don't mind which one you do, or if you're feeling adventurous, you can do both of them. So if you just want to work through them, that is, I believe, the first part of section B, and that is question 1. As you can see, it says question 1. Okay, so if you do have any questions whatsoever, please do not hesitate in giving me a message, or if you want to share your knowledge with the rest of the class, then you can just pop a comment, obviously, within the classroom, and anyone feel free to respond to that. Okay, so that's that. Don't really need to say anything else. But it is obviously your last day before the Eid holiday, so Eid Mubarak to anyone celebrating. If you're not, I hope you have a nice, restful holiday. Okay, take care, guys. See you on the other side. Well, I kind of say see you on the other side, but I can't really see you, so... Anyway, hope to see you. Do take care. Toodles.